What is going on, everyone? This video is about the top AWS services to learn as a data engineer. My motivation for making this video is there's over 200 AWS services, and a lot of people that want to complete data engineering tasks might not know what services are worth learning to solve their data challenges. If this sounds familiar or you just want to learn more about the relevant services, this video is for you. Now, I'm going to be explaining this through a hypothetical example as if I'm a data engineer working for a company and I'm tasked with integrating two different data sources into a central repository to enable our data analytics team to perform advanced analytics to understand our customers better. So hopefully through this video, you'll learn more about these relevant services and how they relate to solving your data challenges. Alright, so our theoretical organization has developed several production applications over the years, and data from these applications are being stored in an RDS database on Postgres and DynamoDB, which can be seen on the left-hand side of this diagram. As a data engineer, I'm tasked with consolidating this data into a central repository on AWS so our analytics team of our organization can perform analytics on our data to better understand our customers. So in order for us to consolidate this data into our central repository to be useful for our analytics team, our first step is we need to ingest the source data from these application databases. There are two main types of data ingestion pipelines we can build to accomplish this. One is batch ingestion and the other is streaming ingestion. Batch ingestion is leveraged when you are bringing in a lot of data at once or on a particular schedule. So our first data source we want to ingest is our RDS database. I want to do a bulk ingestion to get all the historical data over the last year, so batch processing makes sense for this example. So what service can I use? Well, if my tables are small and I'm confident it will take less than 15 minutes to process, I can use AWS Lambda to ingest this data. AWS Lambda is a computing service that runs code in response to events and automatically manages the computing resources required by that code. Now, if my source data has millions or billions of records for each batch job I'm going to run, we're going to need to throw some more computing power and have the ability to run longer jobs. So this would be a good use case for AWS Glue to perform. With AWS Glue, you only pay for the data processing units called DPUs you want to run for your job and don't have to worry about tuning or managing the service after the job is complete. AWS Glue provides both visual and code-based interfaces to make data integration easier. Glue leverages Spark so it can process your data in parallel across multiple nodes for faster processing performance and handling bigger data sets. Now, a lot of people don't know this, but you can also just run Python scripts without Spark on AWS Glue if you don't need the power of a cluster to process your data. Another service we can use to build our data integration pipelines is Amazon EMR. With Amazon EMR, you can choose your open source big data framework such as Spark, Hive, Presto, and the version that you want to use, but unlike AWS Glue, which is a serverless service, you have to manage your cluster of resources, so you need to spend additional time managing the cluster, such as spinning it up and spinning it down when your job is complete. Alright, so we have another application in my organization in which the data is being updated in near real time in DynamoDB. We want to ingest this data as it's being updated in the database. So what service can we use to ingest this data on AWS? We can leverage AWS Kinesis. Kinesis is made up of several components. So if our data is in a DynamoDB stream, we can invoke a Lambda which sends a batch of newly added items to Amazon Kinesis Firehose. What's nice about Kinesis Firehose is it automatically scales to match the throughput of your data and requires no ongoing administration. You only pay for the data you transmit to the service. It can also compress, transform, and encrypt your data streams before loading it into your landing zone, which will be S3. So more on S3 in a bit. So when we integrate our DynamoDB stream with Kinesis Firehose, the end result will be these files that are being exported to S3. We can set these buffer intervals from 60 seconds to 900 seconds and buffer the size of the files from 1 to 128 megabytes for the output file. So in the event we need to perform real-time analytics on our data in Dynamo, we can use Kinesis Streams and Kinesis Analytics together, which provides built-in functions for filtering, aggregating, and transforming data for these advanced analytics. Okay, so we figured out what services we can use to ingest our data from our source databases, but what service can we use to actually store this data? This is where the concept of the data lake emerges. We would use AWS S3 to store all our files that we've ingested from our data sources. Now, it's generally a good practice to land our data in the data lake as raw as possible. Data is quite not ready for consumption for analytics in this raw zone in S3. However, it still may provide value to our data scientists of our organization. A good practice is to ingest all the data from a data source, since data is cheap to store in S3, and perhaps a use case develops later for a particular field that perhaps you didn't see value in the present time. So now that our data is in a raw zone, at this point, we probably want to optimize the storage format in S3 for querying, or clean up our data columns, or perhaps deduplicate some of that data that was landed from our data sources. By performing this, we are making our data clean and more ready for analytics to be performed. So to do this, we can leverage AWS Glue, AWS EMR, or AWS Lambda again to process our data further. So after we finish processing our data, our process data can be written back to S3 in a process zone, which could just be another S3 bucket. Now, depending on your use case, you may have additional zones in your data lake, depending on how much processing you want to do for your particular use case, such as a curtailed zone or a consumer zone, if you want to make your data more consumer ready. So now that we got our data in various zones in our data lake, we need a way to know where all of this data is and what dataset schemas are, so we can keep track of all of this data we've worked hard to process. We don't want our data lake to become a data swamp. AWS Glue Catalog exists within the AWS Glue service and is a central catalog of the various datasets that exist in our AWS account. Now you can populate these datasets in the data catalog directly through the console or through code as well, but Glue crawlers make it easier to discover all of these datasets with no development time needed. AWS Glue Catalog keeps track of where your datasets are in regards to your S3 bucket and object location, the file classification of the dataset, and the schema information about your data. So if we end up using Glue crawlers to update our data catalog on AWS, we can run these Glue crawlers periodically to keep track of our data catalog to make sure it's up to date in the event, let's say, a new column is added to a dataset. Now, if we want to build a data warehouse to analyze terabytes or even petabytes of data, perhaps you have very long-running queries with many large joins. On AWS, we would use AWS Redshift. AWS Redshift can scale up depending on how much compute we need or how large our datasets are. Redshift is an OLAP database, which is really designed to process large datasets across many columns. As a data engineer, you may want to know how to interact with Redshift, such as reading and writing data and designing the architecture of the database. All right, so I'm not going to focus too much on the analytical services in AWS since this is a data engineering focused video, but I'm going to highlight some that I found are useful to know about as a data engineer. Sometimes you need to perform some ad hoc queries on your data, and to do this, we can use AWS Athena. AWS Athena integrates with the Glue catalog, so you can perform SQL queries on tables with your data lake like it was a table in a database. This is a serverless service that you only pay for the terabytes of data scanned. If you're already familiar with SQL, you're going to feel right at home using AWS Athena. And the beauty of this service is if you already have populated your Glue catalog with your various datasets earlier, with minimal configuration of AWS Athena, you're basically ready to start performing ad hoc queries on your data. Now, if you're looking for tips on how to build a data lake that is optimized for query performance in AWS Athena, check out my data lake optimization video in the description below. These tips can save you a ton of money, especially if your datasets are large. All right, so data engineers sometimes wear BI hats and are responsible for building analytic dashboards. On AWS, this can be accomplished with AWS QuickSights. In AWS QuickSights, we can create various graphs and charts to help make sense of our data for end users. One thing I love about AWS QuickSights is it integrates nicely with AWS Athena and AWS Glue Catalog, so we can create dashboards right off the data in our data lake using AWS Athena for compute. So we actually don't need to manage any databases between our dashboard and our data lake. Of course, we can connect QuickSights to Redshift as well if our data resides there or other databases. If you want to present your analytics in the form of interactive dashboards without having to manage servers, QuickSights is the service to use. QuickSights dashboards can be accessed from any device and seamlessly embedded into your applications, portals, and websites. QuickSights also has the ability to do machine learning powered insights, so you don't need a machine learning specialist to take advantage of some ML algorithms. Now, as our architecture diagram comes together, you might notice that our data pipeline may rely on one or more services to complete from end to end. So you might be asking, Adriano, how do we orchestrate or organize the application integration of all these different services? So if you want to implement event-based data integration for your workflows, Amazon Event Bridge is a service that you can use to trigger an event by setting up a rule. For example, we can set up a rule for when a file is uploaded to the raw S3 bucket and then send a notification to another service to trigger a different job to process it further. You can also use Event Bridge as a scheduler to run a Lambda or Glue job. Simple Notification Service and Simple Queue Service are also good services to know about for supporting event-driven applications. For example, for a file that lands in our S3 bucket, we can send a JSON payload to an SQS queue, which can then trigger a Lambda to start processing your files. By creating a queue, we are creating an asynchronous workflow in the event there is more messages in our queue than how many Lambdas we limited to run this process in parallel. You can also combine an SNS topic with multiple queues from SQS if we want to develop a fan-out pattern in the event multiple jobs need to react when a single file drops in S3. If you want to understand more on when to use SNS and SQS, check out Be a Better Dev's video on it in the description below. All right, let's move on to data pipeline orchestration. So sometimes data processing jobs may be rather complex with multiple glue jobs that need to be triggered in a specific order for the job to complete. Well, if you've developed your jobs in AWS Glue already, you can use AWS Glue workflows within the Glue service to create, visualize complex extract, transform, and load activities involving multiple crawlers, jobs, and triggers. Each workflow manages the execution and monitoring of all jobs and crawlers. As a workflow runs each component, it records the execution progress and status. In the AWS Glue console, you can see a visual representation of the workflow as a graph. Now, if you've developed your data ETL jobs leveraging Lambda and perhaps a mix of other services you want to be able to call as well, AWS Step Functions would be the service you want to consider to learn more about. AWS Step Functions has strong integration with AWS Compute Services, database services, messaging services, data and analytics services, and APIs. With Step Functions, you define your workflows as state machines, which transform complex code into easy-to-understand statements and diagrams. AWS Step Function maintains the state of your application during execution, including tracking what step execution it's in and storing the data moving between the step functions of your workflow. One thing I really like about Step Functions is in the event that your step function fails, for example, your Lambda errors out for any reason, you can see where exactly your step function failed and what parameters that were used so that debugging becomes easier and less cumbersome. Now, if your data pipelines you've developed have any errors you want to review or simply want to review the logs that have been generated by all your data pipelines, AWS has a central service that logs and tracks whether you are building your data pipelines with Lambda or Glue jobs, for example. With AWS CloudWatch, we are able to collect, access, and analyze logs from our data pipeline. As a data engineer, you should be fairly comfortable with using the service to understand where all your logs are being stored in the event you need to query them for any given reason. So after we've implemented this architecture, our analytics team of our hypothetical organization now loves me and their job more because they're empowered through the self-service architecture and are now ready to perform advanced customer analytics. Now, I know I just touched the service of these AWS services for data engineering, but I hope it gives you a good idea on what services may be relevant to dig deeper into as a data engineer. And hopefully you can see how this potentially fits in your specific use cases. Thanks so much for watching, and if you want to learn more about these services in more detail, please consider subscribing to my channel as I will continually add more videos on AWS data-related architectures, explaining concept and technical tutorials related to data on AWS. See you next time.